So in this video we are going to solve a 2023 paper, math paper. So the first question is under sets, which we are going to start with, which is saying use set notation to describe the shaded region in the Venn diagram shown below. So I've got my Venn diagram. Now before we describe this Venn diagram, I would like us to put some numbers. Okay, so I'm going to put random numbers. I'm going to put here 1, here 2, here 3, then here 4. Okay, meaning I have set A being having A or having 1, 2, then set B, it has 2 and 3. Now we need also to list A complement. Okay, so my A complement in this case is going to be 1. Okay, so A complement are the numbers except these ones. Okay, the numbers which are not found in A. So the numbers which are not found in A is just 3 and 4. What is our B complement? The numbers which are not found in B. Okay, it's just 1 and 4. So I have 1 and 4. Now after listing these numbers, I can clearly see that this shaded region is only for A and B, but intersection part is not included. Okay, so I'll start now. What if I say A union B? Okay, A union B, I'm going to see that the numbers which I'm going to have for A union B is 1. Okay, I have 1, 2, 3, 4. By the way, when we say A union B, is to add all the numbers which are found in A and B. Okay, so which are found in A and B. Now in this case 4 is not supposed to be included because 4 is outside A and B. Then I'm supposed to exclude this, so I'm supposed to end there. Okay, but now if we can check here, if it is A union B, that is just okay, but again the intersection part of A and B is not included. Okay, meaning A intersection B, this has not to be included, so I'm going to say complement. Okay, now if we can check here clearly, I can clearly see that the numbers for A intersection B complement. What are these numbers? Now in a case where A intersection B complement, these are numbers except the number which is going to be 2, except 2 in this case. So you can use De Morgan's theorem to prove this. It's going to be A complement union B complement. So if I get A, in this case my A will be what? My A complement is 3, 4. Then my B complement is 1. So it's 1, 3, and 4. Okay? Meaning that my A intersection B complement initially is this number, these 3 numbers. Then A union B, these numbers. Okay? But again, which symbol are we going to use for us to put A intersection B complement and A union B together for it to make sense? Okay, so I'll say A union B, I'm going to put complement. Oh, sorry, this is just supposed to be direct. I'm not going to put anything in between. Then I'm going to say A intersection B. Now I have to put complement. So which number am I supposed to put, or which symbol am I supposed to put in between here? Am I supposed to put union or intersection? Now it's a bit difficult for you to know, but I'm going to show you the way. Now here I have 1. A union B is this one. I'm going to put 1, 2, 3. Okay, I don't know what's supposed to be in between. I'll put it, I'm going to leave it blank. So A intersection B in the brackets complement is 1, 3, and 4. Now I can clearly see that the shaded part is just excluding A intersection B. Okay, so if I put intersection inside, initially the answers which I'm supposed to get, I'm just supposed to get, here I said there's 1 3 then 4, I'm supposed to get just 1 and 3. That's all. So if I put intersection here, I can clearly see that the numbers which are found here and there is 1 and 3. Therefore, I'm supposed to put intersection here. So my correct answer for this shading is this one. So the correct answer is A union B, then intersection A intersection B complement. So this is my correct shading. So if I put union here, it would mean to say I'm going to have 1 2 3 4, which is just basically the universal. Okay, but in this case we want to exclude the intersection part. So the correct answer is this one. Okay, so now we can go for the second one. The second one is given that A is negative infinity, comma negative 2, included union 5 not included, positive infinity. B is negative 3, comma 6, included negative 3 6 not included. So the question is find B minus A. They're saying that given that A is equal to this and B is equal to that, a subset of the set of real numbers. So real numbers, these are numbers from negative infinity all the way to positive infinity. Okay, those are real numbers. Now we want to find B minus A. Now B minus A, when we're talking about minus, it's the same as we're talking about B intersection A complement. Okay, so in a case where you have been given A minus B, this is the same as A intersection B complement. Okay, so initially minus is more like we're talking about if we have 7 minus 3, this is going to give us 4. So in 7 we remove 3. So here in A we remove B, that is A intersection B complement. So A intersection B complement meaning we remove B. Okay, so now the best way to do this is to use the number line. Okay, so what I'm going to do now, I'm going to use the number line. I'm going to say here is my number line. So I have negative infinity and positive infinity. Okay, so I've been told to say the numbers which we have here is negative 2. I'm going to put negative 2 here. Then I also have negative 3. What else? We also have 5 and 6. Okay, now I can clearly see that A is saying that A is from negative infinity all the way to negative 2, but negative 2 is included in this case all the way to negative infinity. So negative infinity, I'm going just to put an arrow. Why am I putting an arrow? Because infinity is not a number, so we don't know where it's ending. Okay, so I've put an arrow there. Then the next one, union 5 all the way to positive infinity. So starting from 5 again all the way to positive infinity. There, that is my A. So I have to denote this to say this is my A. Okay, but here negative 2 is included from the question. Here it is crossed. Now in a case where you don't understand this, if you see any question under set interval notation, if they have used this, maybe it's 2 comma 3, meaning 2 is not included, 3 is not included. This is what we call an open interval. There is also what we call a closed interval. So this one, if we say 2 comma 3, meaning 2 is included, 3 is also included. So in this case, I can clearly say that this is a closed one, meaning negative 2 is included in that case. But here it is open one, 5 is not included. Okay? Here it is also a closed one, negative 3 is included. Here is an open one, 6 is not included. Okay? So now 2, since is included, I need to use a circle. I'm going to shade it, a closed one. So when it is included, you are using a shaded one. When it is not included, you are using an open one to show that at that point that number is included or not. Okay? So this is my A. But remember, we are interested in A complement. Okay? So A complement is going to be the part which is not part of A. So in this case, I'm going to get, since this is included, okay, if this part is included, meaning my A complement is not supposed to be included, I'm going to put an open. If this part is not included, meaning the complement has to be included. So that is going to happen to be my A. I'm done. Let's go now to B. Okay, initially we're not interested in A, we're just interested in A complement. So if you want, you can just represent this one alone without showing A. You just show A complement. So this is my A complement. Okay, then now we have B. From our question, since we are trying to find B intersection A complement, my B is from negative 3 included. Okay, negative 3 is included all the way to positive 6. Positive 6 is not included. So that's happened to be my B. Okay, now the part where B, this is my B, the part where B and A complement, they are intersecting, that is our solution, is this part here. Okay, which is negative 2 to 5. So that part is where I'm going to find B intersection A complement. So in this case, my B intersection A complement is, since this is not included, I'm going to say negative 2, but this part is included, 5. This is my answer. Now, when representing your answer, the question is asking us to find B minus A and not B intersection A complement. So you say, therefore, B minus A is equal to negative 2 comma 5, 5 included. Then we are done. So that is it for question 1, 2. So we have question 1b, which is under complex numbers. So the first question, b1, which is saying, given that x and y are real numbers, solve for x and y in the equation. Okay, so we start from there. So I will write the question, which is x plus y I, then plus 1 plus 3i is equal to 1. Now in this case, I'm going to find the common denominator. Okay, so what is our common denominator in this case? So we are going to get what is on the bottom there. I put them in brackets, 1 plus 3i also in brackets. So what I'm going to do now is I'm going to say x plus yi into everything here, meaning this and that will cancel. I'm going to remain with 1 plus 3i. So 1 plus 3i times 1, I will just have 1. I will just have 1 plus 3i. Okay, If I want, I can put them in brackets in a case where there's a negative here, which can affect everything there. But I have a positive, but I'll just put a brackets there. So 1 plus 3i into what is on the bottom there. These two will cancel. I'll remain with this x plus yi. Now x plus yi times 1, I'll still get x plus yi. This has to be equal to 1. Okay, so if I open the brackets on top there, I'm going to continue from here. I'm going to find that I'll have this plus x plus yi. Then I divide this by x plus yi. Then this is in the brackets. I also have 1 plus 3i. This has to be equal to 1. So I can cross multiply now. Here it's the same as this one. I can cross multiply, and I'm going to find that I'll have 1 plus 3i plus x plus yi is equal to x plus yi. Then I have 1 plus 3i. Now I can expand this. Okay, so the left hand side will remain the same. 1 plus 3i plus x plus yi to be equal to, so I'll say x times 1, I'll get x times 3i, it's going to be 3xi. Then yi times 1 is yi. Yi times 3i, I'm going to get 3yi squared. Okay, now remember, when we are dealing with complex numbers, when you see I squared, we replace it with negative 1. So here I have I squared. I'm going to replace that with negative 1. The left hand side remains the same. 1 plus 3i plus x plus yi to be equal to x plus 3xi plus yi plus. So this is going to be 3i times negative 1. Now I can get rid of this part here so that I continue from there. Okay, cool. So what's going to happen now is I'll continue from there. I'm going to say the left hand side remains the same. I'm going just to copy the way it is. 1 plus 3i plus x plus yi to be equal to x plus, I'm just copying this, x plus 3xi plus yi. Now because of this negative, this one now is going to be minus 3y. Okay, cool. Now I can get rid of this. So we continue from there. I can clearly see that on the left hand side I have got x, right hand side I've got x. So I can cancel those two. What else can we see? I can clearly see that I've got yi. Even here yi, these two can also go. In a case where you don't understand what's happening, this is the same as I just shift this to the other side, it's going to be minus. So I'm going to end up having x minus x. Even this one, I'm going to have yi minus yi. So this is going to give us 0 still. That's why I'm just cancelling out there. Okay. So if you're not okay with this, you can first shift this and that to the right hand side. Then they are going to be cancelled out with that. It's going to be 0. Okay. Now on the right hand side, I'm remaining with 1 plus 3i is equal to, the right hand side I'm remaining with 3xi minus 3y. That's all. Now when you reach at this point, we are trying to find the value of x and y. So what we do normally is I'm going to rearrange this. I'm going to start writing this to be equal to that. Okay, so I'll say 3xi plus, which is minus, sorry, minus 3y to be equal to 1 plus 3i. Now after reaching at this point, you compare the complex number and equal to complex number, the real number equal to real number. So in this case, I'm going to say 3xi is going to be equal to 3I. Okay, so I'll say 3xi will be equal to 3I. So I and I will cancel. Then I'll end up having 3x to be equal to 3. I'll divide both sides by 3, both sides by 3. These two will cancel. My x will be equal to 1. So I found now the value of x to be equal to 1. Okay, that's cool. So x is equal to 1. Let's 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 see what will be the value of y. So negative 3y will be equal to 1 because this is a real number. A real number has to be equal to real number. So I'll say negative 3y is equal to 1. I'll divide both sides by negative 3. Negative 3y will be equal to negative 1 over 3. As simple as that. So the value of y is this one, the value of x is this one. If you are trying to prove this, you can plug in the values in this equation. You see that you're going to have 1. Okay. So that is it for B1. We have managed to find these answers. The answer x is equal to 1 and y is equal to negative 3 over 1. Okay. Let's now go to part 2, which is saying express the square root of 7 plus 1 divided by the square root of 7 minus 1 in the form of a plus b, the square root of 7, where a and b are rational numbers. Okay, so in this case, I just need to get the conjugate of the denominator. Okay, so I'll rewrite this plus 1 divided by the square root of 7 minus 1. Now, initially, what's happening here is that the negative, when you are conjugating, you are going to conjugate the part having the square root. So in this case, I'm going to say times. I'll have this one now. The conjugate of this is going to be negative the square root of 7 minus 1. Even here, negative the square root of 7 minus 1. This one will not change. In a case, sometimes if you want, you can rearrange this to be equal to 1 negative 1 plus the root of 7, so that when you're now trying to conjugate this, is going to be minus, which is just the same with what I'm doing there. It's just the same. So I'll continue with this, the one I've started with. So I'll say negative 7 times negative the square root of 7 times times the square root of 7. I'll end up having negative 7. Okay, because the square root and square root will cancel, so I'll end up having negative 7. So I'll have negative 7 here. Then negative 7 times negative 1, I'll end up having negative the square root of 7. 1 times that 1 times the square root of negative 7, I'll have negative square root of 7. 1 times negative 1 is negative 1. The down part, I'll have this times that, I'm going to get also negative 7. Then this times that, I'll end up having the same one which I have on top there, negative 7. Negative 1 times this one, so negative and negative will give me positive the square root of 7. Negative 1 times negative 1 plus 1. So negative 7 and the negative 1 can be added, so it's going to be negative 7 times minus 7 I'm going to have negative 8. Then negative the square root of 7 minus the square root of 7, I'll end up having 2 the square root of 7. I divide this by this, and this will give me 0. They will cancel out. So negative 7 and 1, I'll end up having negative 6. So I have negative 6 here, but the question is saying it's supposed to be in the form of a over b. So meaning I need now to simplify this. So I'm going to say this is the same as negative 8 divided by negative 6 minus 2 the root of 7 divided by negative 6. Negative and negative will go. 2 there 4, 2 there 3. So I'll have 4 over 3 minus negative and negative will also cancel. Here is going to be positive. 2 there 1, 2 there 3. So I'll have the root of 7 over 3. So this happened to be my answer. In this case, a is equal to 4 over 3, and b the square root of 7. In short, b is 1 over 3. Okay, b is 1 over 3 because we have b times the square root of 7. So b is the same as saying it's 1 over 3. So in this case, this is my answer. So that is it for part B. So now let's talk about binomial. So I have a question which is saying find the coefficient of x squared in the expansion of. So I have this expansion here. Now we want to find the coefficient of x squared. So how can you solve this question? So it is very important for us to know that it is possible if I have 2 divided by 3, okay, this can also be written as 2 times 3 raised to the power negative 1. Okay, now sometimes let's say we have 3, or let's say x divided by y now to the power 2. So this can be also written as x times 1 over y squared. That's just okay. But if there is 1 on top, it can also be written as x, then we move 1, this is going to be negative 3, negative 2, sorry. So we have to write this in form of this, using the principle I've given you. Meaning, this can be written as 1 plus x to the power 2 times 1 over 1 minus x to the power negative 3. Now, since here there is already to the power negative 3, for me to remove this negative, when I'm removing 1, it's more like I have, let me give you another example. If I have this negative 2, this can be written as x times 1 over y to the power negative 2. Okay, so initially this is going to be x times y times negative 2 times negative 1, because there's negative 1. Now negative 1 and negative 1, they'll cancel out. I'll end up having this. So this is what is going to happen there. So here I'm going to have 1 plus x squared times this negative is going to disappear now, 1 minus x to the power 3. Okay, meaning the negative has disappeared. Now we want to find the coefficient of x squared. So the best way to do this is just to expand this and that. Okay, so let's see. I'm going to put these ones here. Allow me to put 1 minus or 1 plus x to the power 2, and also 1 minus x to the power 3 here. Then I get rid of this. So this will be equal to, I'll start now expanding this. This is the same as 1 times 1, I'll have 1. 1 times x, 1 times x, I'll have x. Then x times 1, I'll have plus x. X times x is x squared. Now how do we expand this? I'm going first to expand this in two ways. So I'm going to say x 1 minus x. I'll say 1 minus x all the way raised to the power 2 times x minus times 1 minus x. So let me first expand this, then I'm going to do times this. Okay, so I'm going to say 1 times 1 is 1, then 1 times x, I'll end up having negative x. Then negative x times 1, I'll have negative x. Then negative x times negative x, I'll end up having positive x squared. Now this has to be multiplied by 1 minus x. Okay, so we'll continue from there. Then this can be simplified as x plus x is 2x. Then x squared is just alone. I'll put it there. Now I'll start 1 times this. 1 times 1, I'll have 1. But before I do that, I can first simplify this as well. I say 1 negative x plus negative x minus x, I'll have negative 2x plus x squared, then 1 minus x. Now I can simplify better. So I'm going to have 1 plus 2x plus x squared. Then here I'll have 1. I'll have this 1 times 1 is going to be 1. 1 times, okay, I can even start with this. I'll say 1 times 1 is 1, which I've written already. Then 1 times negative 2x, I'll have negative 2x. Then 1 times x squared, I'll have x squared. I'm done with this one. Let's go now to x. Negative x times 1 is going to be negative x. Okay, then negative x times negative 2x is going to be negative, it's going to be positive now, positive 3, positive 2. So it will be positive 2x squared. Okay, cool. So negative x times, now this is going to be negative x to the power 3. Now we can simplify this and say this, I'll just copy this part here the way it is. 2x plus x squared. Now here 1 is alone, I'll not add it to anything, but I can clearly see that negative 2 and x can be added, and I'll end up having negative 3x. Also this and that can be added, I'll end up having plus 3x squared. Okay, then this is also alone, so I'll have x to the power 3. Now after reaching at this point, we're supposed to do times everything, but now the issue is the question is asking us to find the coefficient of x squared. So the coefficient of x squared, you just check which numbers when we multiply they will give us x squared. Okay, so I'll start with, if I multiply 1 with this, I'm going to get 3x squared, so I'll put that one there. So 1 times 3x squared, I'm going to get 3x squared, but let me put it here. I'm going to get 3x squared because we are only interested in x to the power 2. That's why I'm doing this. Okay, next we are going to to check which one, when we do times, anything from the first box or from the first brackets and the second brackets, when I do times, I need to get x squared. If I do 2 times negative 3, I'll end up having 6x squared. So if I do this times that, I'm going to get negative 6x squared. Negative 6x squared. What else? Again, if I do this times that one, it's going to give me, if I do this times that, it's going to give me x squared. We're not x to the power 3, we're not interested in that. This one times that will just give me 2x, we're not interested in that. But again, if I do this x times 1, I'm going to end up having plus x squared. So these are the only x squared values we can get. Okay, now if I add this, I'm going to end up having 3x squared minus 6x squared. I'll have negative 3x squared plus x squared. So this is going to give me negative 2x squared. The coefficient is the number. So in this case, the coefficient is 2, negative 2. So the coefficient of x squared is equal to 2. So in this case, the answer is 2. Sometimes you may think of this. After now expanding to this part, let me just get rid of this. But if you want to waste time, you can say 1 times everything here, 2x times everything there, again x squared times everything there. That is if you want to waste time. But anyway, we don't have that time. But sometimes what you can do is, you know that this and this can give you x squared. So since we are interested with the coefficient, you just say 1 times 3, then plus. Okay, now you come to which else? If I come to 2x times this is going to give me x squared. So I just get the coefficient. So I'll say 2 times negative 3, which I'm going to put it there, plus the last one I think is this times that one. So it's 1 times 1. 1 times 1. So here I'll get 3. Here I'll get plus negative 6. Here I'll get plus 1. So still I'll end up having negative 2. That's my coefficient. So that is it for this question. We have another question for binomial expansion, which is saying find the term independent of x in the expansion of. So this question had 4 marks. So now when we say find the term independent of x, it is a term which does not have x, okay, in expansion. Let's say you have got an expansion which is maybe 3x squared minus 3 plus 4x to the power 3. Now expansion independent of x, which doesn't have x, in this case is this negative 3. So that's what we want to do. Now for binomial, we need first to take note to say it is all coming from the binomial theorem, where we are saying n choose r, then a n minus r times b times r. Now this formula is very important. In this case, n is the number which we are going to be given. Any number which is the power here, that is our n. So in this case, our n is 12. Now this is always in form of a plus b. So now let me give it like this. It's more like we have a plus b to the power n. So this one, the formula always is n choose r, then we have a n minus r times b to the power r. So in this case, the first number which you are going to be given is your a, the second number is your b. Okay, meaning in this case my a is a 2x squared, my b is a negative 1 over x to the power 2. R is the one first I need to find, because we are saying that for us to find a term independent of x, I need first to find the r, because I'm supposed to expand this. A then n minus r, b times r. So first you have to write this formula. After that, now plug in the values. So my n is 12. R is the one I don't know. In this case, I want to find my r. A is 2x squared. So I'll put 2x squared to the power n. I know n. N is 12 minus r is the one I want to find first. What else? My b in this case is negative 1 over x to the power r. R in this case is the one I don't know. Now, a term independent of x, it is a term where x is to the power 0. In a case where you have expanded your binomial, then you come across 3x to the power 0. So any number to the power 0 is 1. So in this case it will be just 3. Meaning that x to the power 0 is going to be a term independent of x. So what do? We have to equate this equal to x to the power 0, because we are trying to find first the value of r. So after finding the value of r, I'll come back and plug in the values here. That will be the term independent of x. Okay? Once I find the value of r, I'll come and plug in the values. That is going to be a term independent of x. Now, we know that this one can be written as, in this case now I'm going just to ignore, you always ignore the coefficient, because we are only interested in x. We are trying to find the value of r, so we are going just to be interested in x, even here in x. But now this is going to be x to the power 2, then I have 12 minus r. This is negative 1 over x, which is the same as negative 1 times x to the power negative 1. So now I have got x to the power negative 1, then I have also r. This r has to be equal to x to the power 0. You always ignore the coefficient, please. So I've ignored this, I've also ignored this, because I'm only interested in x. But now after finding the value of r, I'll come back and plug in the values there and find the answer. The answer I'm going to find there, that will be a term independent of x. So there we go. I can clearly see that this is going to be x. 2 times 12 is going to be 24 minus 2 times r, it will be 2r. Okay, so now if the bases are the same, we add the powers. So now this is going to be added. This is the same as negative r, so I'm going to say minus r is equal to x to the power 0. So since these are the same, you just equate the power equal to each other. Okay, so in this case I'm going just to equate the power, which is going to be 24 minus 2r minus r is equal to 0. So it will be 24 minus 3r is equal to 0. Then I'll shift now 24 to the other side. So I have negative r is equal to negative 24. Divide both sides by negative 3, both sides by negative 3. So these two guys will cancel, meaning my r is now equal to negative and negative will cancel. 3 into 24 is 8. Now that I have found my r, I need to go back and find my term independent of x. Okay, so I'll get rid of this now. A term independent of x, I said, if I plug in the value of r, listen, if I plug in the value of r in this equation, when I'm trying to find the answer, you discover to say this x is going to disappear, because we are finding a term independent of x. If you discover that x does not disappear, meaning your r is wrong. Okay, so let's see. As long as they cancel out, as long as the x cancels out, then your r is correct. So I'm going to say, I'm going now to plug in the values. I'll say 12, my r now is 8. Then I'm going to say 2x squared. So I have 12 minus 8. Then here negative 1 over x to the power 8. Let's see. So we are saying r is 8. I can now get rid of this. So I'll have 12, choose 8. Then this is going to give me 12 minus 4 is 12 minus 8 is 4 on top here. So I'm going to have now 2x squared to the power 4, okay, times negative 1 over x to the power 8. Okay, next I have 12, choose 8. Then I can clearly see that this is going to be 2 raised to the power 4 is 16. Then x squared times x squared to the power 4, meaning is x to the power 8, times here I can clearly see that negative 1 raised to the power 8 is going to be positive 1. Then x raised to the power 8 is x to the power 8. Now I can remove the brackets. This one I'll just bring it the way it is. Temper it, don't temper with it. Just bring it the way it is. So it's going to be 16 x to the power 8 times 1 over x to the power 8. Now we can clearly see that x to the power 8 and x to the power 8 can cancel. The moment you see that x is going, that is a term independent of x. Now I have 12, choose 8 times 16. Now I need to find the answer for this. So I'll do it from here. I'll do it from here. So I'll say 12, I'll just write, choose 8 times, I'll just put a dot, that is times 16. So 12 is 12 factorial over 12 minus 8 factorial times 8 factorial. This is coming from here. Let me just show it here. If you happen to have n, choose r. This is n factorial over n minus r in the brackets factorial times r factorial. So in this case our n is 12. That's why I've put 12 factorial. Then my r is 8, so it's 12 minus 8 factorial, then times 8 factorial. Okay, now so I'll have 12 factorial. Here I'll have 4 factorial times 8 factorial. But we should remember to say we need to do times 16. Okay, so even here as we are doing this is times what? 16. This will be equal to 12 times 11 times 10 times 9 times 8 factorial. I'm going to end on 8 factorial because even down here I've got 8 factorial. But this 4, I'm going to say 4 times 3 times 2 times 1. Then times 8 factorial. So 8 factorial and 8 factorial can go. Okay. Then 4 into 12, it goes there 3 times. 3 and 3 can also go, meaning I've remained with 2 down here. So I'm going to say 2 into 10 is 5, meaning I've remained with here there is also times what? Times 16. I've remained with 11 times 5 times 9 times 16. So the answer I'm going to find there, 11 times 5 is 55. Then what is 16 times 9? So 16 times 9 is 144. So 144 times 55, that is going to give me close to, I can just do it here. So 144 times 55. 5 times 5 is 20. 5 times, or 5 times 4, sorry. 5 times 4 is 20. I'll write 2. I'll write 0. I'll write 0 carry 2. 5 times 4 is 20. So 20 plus 2, 22. I'll write 2. Then 5 times 1 is 5 plus 2, 7. Next, this is also 5. I'm expecting to have the same. I'm going to have 0. I'm going to have 2. I'm going to have 7. I add, I'll have 0, 2, 9, 7. So it's 7,920. So a term independent of x is 7,920. So in this case, this is my answer for this question.